A single bee weighs less than a paperclip. Its brain is smaller than a grain of rice. And yet, drop one bee into a hive of 50,000 others, and something strange happens. No one is in charge. There's no manager handing out shifts, no architect drawing up blueprints, no general planning the next move. And somehow, that hive builds a perfect geometric city, feeds tens of thousands of mouths, defends itself from invaders, and survives winters that kill most other insects outright. So how does a brain the size of a sesame seed help run something this complicated? Let's go inside. Here's the first thing to unlearn. A beehive isn't really 50,000 individuals. Biologists have a term for it: a superorganism. Each bee is more like a single cell in a much larger body. A skin cell can't survive alone outside your body for long. Neither can a single bee. Pull one worker out of the hive and she'll die alone within a day or two. Not from injury, just from isolation. She needs the colony the way your heart needs your lungs. So when we ask, how does the hive make decisions? We're really asking the wrong question. The hive doesn't decide anything the way a brain does. It decides the way a body regulates its temperature, through thousands of tiny local actions that add up to one coordinated result. Let's start with the bee everyone's heard of, the queen. Despite the name, she's not a ruler. She doesn't give orders. Her entire job for her whole life is laying eggs. Up to 2,000 a day during peak season. That's more than her own body weight in eggs, every single day. She mated once, early in life, with 10 to 20 drones in a single afternoon, and stored their sperm for the rest of her life, which can be up to 5 years, compared to a worker's 6 weeks in summer. The colony controls her, not the other way around. If she gets old or stops laying well, the workers will quietly raise a replacement, feeding a handful of ordinary larvae a special diet of pure royal jelly, which switches on the genes that turn an ordinary female larva into a queen. It's not royal blood. It's royal food. Then there are the workers, and almost the entire hive is workers, all female, all daughters of the queen. And here's the part that breaks the worker bee stereotype. A single bee will hold several different jobs across her lifetime, and the order is almost always the same. She starts as a nurse, feeding larvae and capping cells. A few days later, she's a builder, producing wax from glands in her abdomen to construct perfect hexagons, the most material-efficient shape possible, which is why bees have been building them for millions of years before humans ever discovered geometry. Later, she becomes a guard, standing at the entrance, smelling every bee that tries to enter to make sure it belongs to this colony and not a rival hive. And only at the end of her life, usually her last 2 or 3 weeks, does she become a forager, flying out to collect nectar and pollen. It's the most dangerous job in the colony. Most foragers die out there, from exhaustion, predators, or simply not making it home. The hive assigns its riskiest job to the bees closest to the end of their lives anyway. So if there's no manager, how does a forager tell the rest of the hive where the good flowers are? She dances. It's called the waggle dance, and it's one of the only known examples of abstract symbolic communication in the insect world. The bee moves in a figure-8 pattern. The angle of her waggling run, relative to straight up, tells the other bees the angle to fly relative to the sun. The duration of the waggle tells them the distance, roughly 1 second of waggling per kilometer. Other bees crowd around her, feel the vibrations with their antennae, memorize the directions, and fly straight to a flower patch they've never seen, based entirely on a dance performed in the dark. The same no-boss logic runs the hive's climate control. Bees need their brood kept within about 1 degree of 35 Celsius. Too cold or too hot, and the larvae die. There's no thermometer, no single bee checking the temperature and shouting orders. Instead, individual bees just react to what they personally feel. Too hot. Bees near the edges start fanning their wings, and others go fetch water to spread across the comb for evaporative cooling. Too cold. bees cluster together and vibrate their flight muscles like tiny furnaces, raising the temperature through sheer numbers. No single bee knows the hive's overall temperature. Thousands of bees, each reacting only to their own little patch of air, add up to a colony that holds its internal temperature steadier than most modern buildings. The colony defends itself the same decentralized way. A guard bee that detects an intruder releases an alarm pheromone, a chemical signal that says, roughly, danger here. Nearby bees pick up the signal and release more of it themselves, and within seconds, the warning has relayed across the entire hive without a single bee giving an order. If a bee does sting, it's almost always a suicide mission. A honeybee's stinger is barbed, so it lodges in skin and tears away from her body when she pulls back, along with part of her abdomen. She dies within minutes. It's a one-way decision made in an instant for a colony she'll never personally benefit from again. That's the strange trade-off at the center of the whole system. Almost every individual bee's life is short, replaceable, and frequently sacrificial. And that's exactly what makes the colony as a whole so resilient. But this same design has a weakness. The colony is only as healthy as the sum of its parts. When something disrupts enough individual bees at once, pesticides, parasitic mites, habitat loss, disease, there's no backup manager to step in and fix it. The superorganism doesn't fail gracefully. It can go from thriving to collapsed in a single season because there was never a single point of control to begin with, just thousands of small decisions that this time didn't add up to survival. It's the same trait that makes the colony brilliant and the same trait that makes it fragile. So the next time you see a bee landing on a flower, you're not looking at an individual making a choice. You're looking at one cell of a much larger, much stranger organism. A body with 50,000 legs and no brain in charge that somehow still knows exactly what it's doing. If you enjoyed the video, don't forget to subscribe and share the video. See you in the next one.